Alright, in this problem we're going to do what about angles, an example from the notes. So here's our situation. We have a mass hanging by two ropes, and we're going to solve for both of the tensions in those ropes. To give ourselves a little bit more room, I went to a different slide. So here's my mass. I've got tension 1, tension 2, force of gravity down. So that's step 1 out of the way, drawing the forces. Step 2 is adding our positives to the up and right direction and negative going down and to the left. Step 3, I need to write my components of any force that goes at an angle. Tension 1 does go at an angle, so I'll draw the y part going upward, and the x part goes here to the left. Now I have to solve for what x and y are. Now the x is the adjacent side to this angle, so that means I'm going to use the cosine of 30 degrees times the hypotenuse, which is t1. I don't know what t1 is, but that's okay. For the y, that's the opposite side, so that means I'm using the sine of 30 degrees. Again, multiplied by the hypotenuse, which is t1. So step 3 is finished. Step 4. Step 4 is adding up all of my forces that go up and down and left and right. Now left and right, I do not know what T2 is, and I do not know x, so I probably don't want to start there. I know something about force of gravity because I have the mass, so I'm going to start in the up and down direction. So in the up and down direction, I have y that goes upward, minus my force that goes downward, and that's force of gravity. I am out of up and down forces, so that equals 0. I know then, with a little bit of algebra, that y equals my force of gravity. So I can plug in. I already solved for what y is right here. So instead of y, I can write sine 30 degrees. And that's multiplied by t1. And that's going to equal my force of gravity, which we learned in class is mass times g, which is 9.8. We're trying to solve for the tension right here, so I can just divide mg by the sine of 30 degrees. In case you forget, the mass given in the problem at 10. So once I plug in my numbers, I would get that T1 is equal to 196 newtons. So now I have to go to my left and right direction to get my T2. So in my right direction, I've got T2. Left, I've got x. I know that equals 0. So math tells me that T2 has to equal x. So T2 equals, we solved for x earlier, that is the cosine of 30 degrees times T1. And since we now already know what T1 is here, we just have to multiply it by the cosine of 30 degrees, and I get the T2 is 169.7 newtons. And then we're done.